Hi guys, and welcome. It's been a little while since we've done one of these videos. I'm sure that we've all missed it just as I have making it. But regardless, what we're going to get into today is we're going to start to talk about randomness, and really the heart of this next unit is about how we come up with the data that we've been analyzing since chapter 2, which is really where we started the textbook. Data has a source, and we have to make sure that in our selection of data that we're doing a decent job of representing the group of people or the group of objects we care to know about. And at the heart there of the selection process is randomness. Think about if you've got, you guys have experienced this in class, maybe it's not so popular when you're upperclassmen, but a lot of the freshmen, man, they go crazy if I offer them the ability to pass out graded papers. Like, I'll have 5 kids at the same time just be like, yeah, I'll do that, Mr. Shelton, I'll do that, Mr. Shelton. And I really only need like 2 or 3 people to help, and past a certain point, it just gets counterproductive because you got a bunch of people walking around the room, and it's just crazy. They bump into each other, they're less efficient, blah, blah, blah. So rather than me choose 3 people and choose, I don't know, based upon whether or not they're close to the front of the room or whether or not I prefer that student over someone else, those are obviously not fair methods of choosing 3 of 5 students to pass back the graded papers. Students, are, however, seem to be totally okay with me saying, well, I've got a number between, say, 1 and 10 or 1 and 100. You guys pick 5 numbers, and whichever 3 students are closest to that number, I'll let pass back the graded papers. Now, is that a truly random method of selecting 3 people to help me pass back graded papers? No, but in the process of setting up something that at least seems random to them, they're okay, and they don't sense any favoritism, and it's an easy way to deal with the problem. Okay, same thing that we're going to see later in this unit come up again and again and again. If you can introduce a method of selecting people or selecting objects or selecting numbers or selecting letters, whatever it might be, if you can introduce a method that is random, you're going to get around the issue of bias in the selection process. Okay, so that's the first thing that this chapter is doing. The second thing that this chapter is doing is it's serving as a sort of prelude for probability. Like, what's the probability that you see a head in a coin flip? You guys would obviously know 50% without having seen any of the probability rules. Or maybe you would think 1/2. Same sort of idea. Okay? So, excuse me. Oh, that was gross. So 2 things going on in this chapter. We're going to talk about the importance of randomness and the importance, and we're going to start to look at probability kind of as a result of that randomness. All right, so what we're going to start with in this first slide is the seeding of your calculator, so your calculator can generate what are really called pseudo-random numbers. Now, your calculator, being a machine, it doesn't do a perfect job of producing, let's say you want to produce random numbers between 0 and 9. It's not going to do a perfect job of bouncing around randomly without any pattern, but it does a pretty good job, and it does a good enough job that we're going to use it in this chapter to make some conclusions about likelihoods. Okay, but to get that done, you first have to make sure that your calculator is seeded, that it basically needs a starting point for this generation of random numbers that the calculator is going to do for us. For some reason, Wabbit is being a little silly. Let me pull it up one more time here. I'm actually not going to demonstrate a whole lot with it today because I don't think it's a lot of what we're going to do here is easily understood the first couple of times we run through it. But okay, regardless. It says in the instructions of seeding, you're going to type any 4 consecutive numbers from, and I put here, this was last year's notes, the random number table under your calculator. You could. The random number table is going to be available, and you really should either print off or at least download to view the random number table that's going to be along with the notes for this video in the calendar on My Big Campus. That random number table we're going to refer to at the end of these notes. You could use the last 4 digits of your phone number. So I could use here, that's going to give you a relatively random starting point, 8926. Then you're going to store, and I believe it's math. You go to probability, hit rand, and that's the seeding process. Now your calculator has a starting point for generating random numbers. Okay. So let's see how this works. Let's see how the calculator can do this simulation of random numbers, or generation rather of random numbers. Let's say we want to simulate the flip of a coin. We'll start with something basic. Obviously, a coin toss has 2 outcomes. You either have a head or a tail. So what we're going to use is the calculator function math, probability, down here to randint. And it takes, it can take 3 arguments. That's 3 different numbers that you would input here. First time we're going to use it, we're only going to use 2. We'll do 0, 1. We're telling the calculator we want an integer, randint after all, stands for integer, to be either 0 or 1. If I put 0, 100, it would give me a random integer between 0 and 100, etc., etc. Okay, so randint gave me 1, and there you go. If I had said in advance, and it's important to do this in advance, if I had said that 0 is going to represent a head, 1 a tail, I would have just simulated the toss of a coin with tail being the result. Okay, so there's your explanation to the question right here. I'm not going to write that out. Next slide. Obviously, generating a single random number of either 0 or 1 doesn't speed up the process of simulating a lot of coin tosses very well. Let's speed the process up for multiple trials, and this is where we're going to start to use a third argument. So if I hit, as the instructions are saying here, back to math, probability, down to randint, and I put, I need a little bit more space, 0, 1, 5. The last argument, that last number, is the number of times that is to be repeated. So we got a 1, a 0, 0, 0. Okay, so I'm going to go ahead and write that out. Why? Not entirely sure because you just saw it, but whatever. Sometimes it just feels good to write. Okay, so what happened? Well, the last argument told the calculator how many times it was to generate a random number between 0 and 1. Okay, so rather than hit randint 0, 1, 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 you can abbreviate in essence. Okay, so now let's see if we can't have the calculator find the number of heads generated in 100 trials or coin tosses all at once. Okay, so rather than, we've got this abbreviation now that our calculator can generate these random numbers multiple times. Let's see if it can also tabulate, add up all the outcomes that we care about. Okay, so let's say that in this particular case, 0 is a head in our simulation and 1 is a tail in our simulation. Okay, so from the catalog menu, which you guys used, you've been there before to turn diagnostic on, we're going to hit S because alpha's on. You're going to hit S, that'll take you to all the S starting functions, and we're going to go sum. There are a lot of S functions in here. There it is. Sum, and within those parentheses now go back to math, probability, go down to randint, hit 0, 1, 100. Close those parentheses, which you had 2 open parentheses, so you should need 2 closed parentheses. Hit enter on that, and the calculator gave you the result of 47. So, because we told the calculator to add up all the random digits it was generating, we just found, with sum, randint, whoop, can't spell randint, R-A-N-D-I-N-T, 0, 1, 100, close, equal to 47. What happened? Well, obviously, we got the result 47. Why does this work as a way of seeing the results of 100 coin tosses? Well, because the heads are zeros, if we're only adding up the ones, were only keeping track of when we had a tail. And because each outcome of an individual coin toss was a 0 or a 1, that 1 represents that single outcome of a tail. It's not representing multiple outcomes here. Okay, so what we found is that with this particular random scenario, we got 47 tails out of 100 tosses of the coin. Okay, and I think that tends to be pretty clear for people. I don't think that I have any need to belabor the issue there. Okay, so let's go ahead and introduce some important vocabulary, and this truly is important. This is really on top of understanding how to generate random numbers, understanding this vocabulary is essential to, long story short, getting a lot of points whenever you do a simulation. And that's what the heart of this chapter is, doing simulations, using random numbers, looking at likelihoods, etc., etc. Okay, so random. An event is random if we know what outcomes could happen, but not which particular values will happen. So obviously, an example there would be randant from 0 to 1. We know, I don't need to write that out. I think I can just leave that and then discuss it. We know that the outcomes are a 0 or a 1, but obviously we don't know in advance which the calculator is going to give us. So a simulation, this really, I'm going to discuss after I discuss a trial. Trial needs to be mentioned first. Simulation component then would be next. And normally you'll hear me just refer to component. It's the most basic situation in a simulation in which something happens at random, okay? So let's say, as an example, that I was using rand int 0, 1, 100. Okay, so as we know from what we've seen before, that's going to give us 100 random digits, but either 0 or 1. A component would be one of those 100 digits. That is the most fundamental random event that can occur. Okay? Now, you could think of all 100 digits also being, that are generated by the calculator, also being a random event. But that's not the most fundamentally small event that's occurring here. The most fundamental is that single digit generation by the calculator, and that process is repeated 100 times. So component, the tiny little granular molecule-sized random event that's occurring. An outcome, an individual result of a component of a simulation. Well, an example here, if I use randint 0, 1, and I get 0, using equals there is kind of a funky notation. Why don't I use arrow? If I'm given 0, then this guy right here is your outcome, okay? That varies from random event to random event. The trial, okay, so the trial, let's see, what example did I come up with? Yeah, okay. So for a trial, randint 0, 1, 100, referring back to this example, that would be the trial where we've got 100 components here, 100 fundamentally small simulated flips of our coin, and this would be the trial if we care to know what those 100 flips are going to look like, okay? Now that's tied to a simulation. A simulation is going to be, and I don't need an example here because we're not seeing an example of a simulation next. I think that's going to come up next slide. A simulation is going to be a collection of repeated trials. Meaning, if I want to know what is going to be the outcome of 100 tosses of a coin, and if I only generate 100 random integers, which are either 0 or 1, well, that's not very fair. I mean, I could get a really, using a term that I used on the first slide, I could get a really biased result. Maybe I see that I had 90 heads. If I'm reporting that I think, based upon that one particular trial where we ran 100, we had 100 digits, either 0 or 1 generated, and I got 90 zeros here, well, I mean, that's not fair. That's probably not a very likely outcome. And we'll get to, when we start to discuss probability, we'll get to talking more specifically about why 90 heads out of 100 flips of the coin, or 100 random digits between 0 and 1, is ridiculously unlikely. So the simulation does a trial after a trial after trial after a trial. Think the experimental method, okay? You set up a trial, you run your trial, but the trial needs to be reproducible, okay? If you can't reproduce the trial, then your results don't really matter. Same thing here in statistics. You're going to set up a trial, you're going to run a trial, you're going to do that a few times. That's the collection of all those trials is your simulation. All right, and that'll make more sense in context. I think next slide is when we're going to do it first. Response variable is, that records the results of each trial with respect to what we were interested in. Look at what I wrote down as my example here. Okay, I like this. So, referring back up to the randint 0, 1, 100, being the 100 flips of the coin, heads or tails, a response variable could be, and these have to be defined like you did, you defined variables prior to using them in story problems in Algebra 1. Perhaps it's capital Y equals number of heads and 100 simulated coin flips. Okay? The response variable will change from problem to problem, and really the response variable is the thing you care to learn about through your simulation. All right, moving right along. Okay, so first simulation. Let's see if we can use our calculators to simulate another real-world event. Suppose a basketball player has an 80% free throw success rate. How can we use the random numbers our calculator can generate to simulate how many shots she might be able to make in a row without missing? Okay, so we've got our calculators as a tool. They can generate lots of random integers for us. That's good. A component here is the most fundamentally basic thing that's going to occur in our simulation. Simulation is the biggest thing that we're doing. Component, again, is the most basic random event. Component would be the simulated free throw. Okay, that's it. 2, specify outcomes of the components, hit or miss. Okay. Now, 3, this is where sometimes it's going to require some thought. Now, I don't think this one's too bad, but you got to be careful with these. We want to connect the random numbers to the component. So we need to think through what types of random numbers do we care to generate. Well, if we've got an 80% free throw success rate, obviously that means, I'm trying to think if there's anything I want to write here to help explain this. I think this is intuitive, so I'm going to go with the intuitive explanation. 80% free throw success rate. We can actually just use the random numbers between 1 and 10 to represent the outcomes of this free throw shot, where 80% of the digits, or 8 of them, can represent the hit, and then 20% of the digits, or 2 of them, can represent a miss here. Okay, so we're going to say, let randint from 1 to 10, and here, you guys are quick. You might realize that I am making an exception here. I'm using calculator notation where I told you guys it's not going to matter. It does matter here. And the reason why is because on the AP exam, when you do simulations, they do not want you to use your calculator. I still care to teach it both without the calculator and without. And without will include the use of the random number table, which we'll get to later in the notes. But long story short, because this particular method of simulating won't be on the AP exam, feel free to use calculator functions. So let randint between 1 and 10, I'm going to go back to red here, represent the simulated shot. Okay, I will say 1 through 8 is a hit. 9 through 10 is a miss. Okay? All right, so there you go. We've connected the random numbers that our calculator is going to generate for us to the component, to the that fundamentally small random event. Okay, so a trial. Trial really depends upon what they're asking for here. We said, how can we use the random numbers a calculator can generate to simulate how many shots she might be able to make in a row without missing? So the key is both to understand what you're being asked to do, how many shots will she make without missing, that's the first thing. But then secondly, and this is what gets missed when people define a trial, they forget to describe how the trial concludes, okay? So in defining a trial, you are describing a process through which the reader will know when to stop generating random numbers. If you're not doing that, you've not well defined your trial. So here, the trial is going to be the random generation of numbers in the interval from 1 to 10. I'm using those brackets to say I'm including those numbers until we see a 9 or a 10, okay? We stop as soon as she has missed, okay? So we're going to see how many shots can she get in a row. That's what the trial is, all right? And we're going to repeat these trials. Again, just like the scientific method. Repeat to see what's generally going to happen, okay? So the response variable also, like how we define the trial, depends upon what's being asked for. They said how many shots might she be able to make in a row? Well, let's define y, perhaps, to be the number of digits, randomly generated digits, minus 1. Now, why do I do that? Well, for each trial, if we're going to get results like 5, 4, 3, 10, well, okay, so we just took 4 shots, and on that 4th shot, we got a miss. We wanted to know how many shots can she make in a row. Obviously, that 4th shot, the last shot of every trial, will be a miss. That's when we stop the trial, after all. That's how we defined it. So we're going to keep track of the number of randomly generated numbers, minus 1, minus the last one. We don't care about the miss. Okay, so now 6, 7, and 8 we're going to do in the next slide. We're going to run the trials, we're going to analyze the response variable, and we're going to state the conclusion in context. Okay, so all we need to set up the simulation, once you've defined those key things on the previous slide, and by the way, I do care that you're defining those things. Come test time, it's going to be important that you have defined your component, you've specified the outcomes, connected the random numbers to the components, defined your trial, and the response variable. Once you do it a few times, I don't think it'll be too big a deal. So this table is going to have, for the first column, the trial number. We've got the outcomes here in the middle. A lot of space for that because potentially this girl could make a lot of shots in a row. So we just want to make sure that we've got plenty of room to tabulate that. And then your response variable in the last column, that was y. That's the number of shots she's making consecutively. Okay, so for trial number 1, 2, 3, 4, 5. Oh, okay, 6. 3, 4, 5, 6. Now, the number of trials I'm including in the notes is small. It's only 6. I want you guys, whenever you run a simulation, to run 20 or more trials. Now, that is just for the sake of making sure that you can make good generalizations. I'm only running 6 here in the interest of time because there's no sense in me doing 7 through 20. I think you can get what's going on if I'm only doing 6. But I'm going to get very different answers if I only run a few trials because I could get some, maybe for trial number 1, I'm going to get 35 shots hit consecutively, as unlikely as that may be. And that's going to really skew my results. Okay? But if I'm running 20 trials and I've got, for trial number 1, 35 shots hit consecutively, it's going to be balanced out by the fact that the 19 other trials probably won't look that way and will give me a fair estimate of how many shots she can make consecutively. All right, so trial number 1, the outcomes here. This is where I'm not pulling up the calculator. I've already done this. I used, for each of these trials, as a heads up, randent 0, 1, 100, which may be overkill, but that way I don't have to hit randent 0, excuse me, not 0, comma 1. I did 1, comma 10, comma 100. There we go. So I'm generating random integers between 1 and 10 100 times, and I'm just looking for the first 9 or 10, knowing that I've stopped the trial, that we've said, okay, you've made your first miss. We got what we needed. Okay, so for trial number 1, I got results of, oh, silly me. Okay, I should have looked at how I'd done this. When I set this trial up in my notes, I did 2 through 10, excuse me, 3 through 10 was a hit, and I let 1 or 2 be a miss. Okay, so I've still got 80% of the random numbers generated being a hit, reflecting that she's got an 80% success rate. I still have 20% of the random numbers being misses. Okay, so sorry for the confusion. So I got numbers that were 8, 9, 9, 3, 9, 1. So the response variable, again being the number of randomly generated digits minus 1, would be 5. She had 5 consecutive hits. For 2, I got a lot. I got 4, 6, 8, 4, 7, 6, 9, 3, 10, 3, and then 1. So we had 10 consecutive hits here. And then for the third, I had this crazy result. I had, I'm going to try to write these small, 8, 9, 4, 8, 8, 8, comma, comma, comma. 9, 6, 10, 5, 9, 10, 6, 5, 3, 8, 3, 7, 7, 3, 8, 3, 7, 7, 9, 3, 4, it just kept going and going and going. 6, 3, 9, 8, 1, which way over here you got your response variable separated from the rest of the pack of 22, I think I saw, being the number of consecutive hits. Just an absolutely incredible result, and part of the reason why when you set up your table to run a simulation, you want to make sure that you've got plenty of width in the middle for the outcomes. Okay, fourth trial. I knew this would happen before I ran this trial. I got a 1, so she got 0 consecutive hits. That cracked me up. Fifth trial, I saw a 3 and then a 2, so 1 consecutive hit. Sixth trial, I saw a 10, 2, and a 1, so 2 consecutive hits. And in my notes, because apparently I can't count the number of rows, I had a 7th trial with results of 7, 9, 5, and 2, so 3 consecutive hits, meaning that, so we need to make a conclusion off of this, and the way that we do that tends to be the following. You're just adding up the results from the response variables and dividing by the number of trials. So, if again, the question was, how many shots can she expect to make in a row? We would say, well, based upon our simulation, notice again that the simulation is a collection of trials. We see that she is likely, don't use probably, okay? Stay away from words of probability. Stay away from anything that really begins with prob at this point, because we've not done a mathematical analysis of how many shots she's likely to make, okay? We're just simulating, okay? We're getting there. We're almost to a mathematical analysis, and that'll come up, I think, starting in chapter 14. We're not there yet, so don't use don't use the probability of such and such a result is this percent. Don't stay away from that sort of language. Based upon our simulation, we see that she is likely to make. Let me see. Okay, And the way that I'm going to write this, y sub 1 plus y sub 2 plus onwards and onwards up to y sub 6 plus y sub 7 all over 7, okay? So what are these y sub 1s, y sub 2s? Well, it's the result for each one of these trials. So y sub 1 is equal to 5, y sub 2 equal to 10, y sub 3 equal to 22, etc., etc. So that's equal to 5 plus 10 plus 22 plus 0, 1, 2, 3. That's easy. 1, 2, 3 divided by 7. So we're taking an average here. Equals 6.143, or approximately 6 shots. So let's see if the wording is correct. Based upon our simulation, we see that she is likely to make approximately 6 shots consecutively. And there you go. There's your first simulation. Let me check the time here. 30 minutes. Okay. Yep, let's stop there. We will resume these notes in the next video. We've hit the heart of the content, and the only thing that's left lingering at this point is how to run a simulation with a random number table. And I'll go ahead and post that random number table in the event that has on the calendar that has these notes, but it's going to be more essential for the next video. So I'll just go ahead and preface that next video by saying go ahead and have access to that. Download